loop going on yours? Yeah, I see it. Experiencing time dilation. Please stand by. Yeah. I want to build one of these actually. I need to make one. Yeah. Oh, that's clever. I can hear myself. I can hear us talking in the background. Yeah. So you'll want to turn off. But can people hear me? So again, hey everyone, I need some kind of confirmation that people can hear me. So if you can, all right, we need someone to acknowledge our existence on either my channel or on your channel. So any one person to just tell us that we exist, to just confirm.
Let me try this.
I can't hear
Okay,
you.
can you guys hear us now?
Working.
Okay, no audio. No, I did something wrong. That's not cool. Oh, can you hear me now? People from the What the Math channel, do you hear me?
Yeah.
Just very low. Okay, I'll turn it up.
Audio,
How about
yeah.
now? How about now? Can you hear me now? It's like the commercial. Can you hear me now?
I wonder if it's going to be delayed. I should look at see. We are
Can you hear me
we are
now?
absolutely breaking the laws of physics here.
Oh, okay, we can hear you both. Is volume fine? Yeah, we definitely broke some laws of physics here.
Yeah.
Yeah. So my face is full
Now it's
delayed.
loud. Now it's too loud.
Yeah, I know my face is delayed, and in the way that it's not synced with the sound, I think.
Yeah.
And that's probably because I am in South Korea and Fraser is in Vancouver. So as you know, the speed of light is a little bit slow.
Now people are saying they can't hear me yet.
Oh, okay.
Oh, they can hear both. Okay, I think we've got it figured out.
Oh yeah, it says I only hear Anton. Okay. Wait,
yeah, but now it looks like they've got it here. So, all right. So just to let everybody know what is going on here. So I'm Fraser Cain, publisher of Universe Today. Every Monday I do a live QA on my channel called Open Space, where I bring in a guest, I answer people's questions about space and astronomy. Anton Petrov does an amazing channel called What Da Math, and we're going to get into that in a second. But he is someone that a lot of people have asked for me to interview here on my channel, and I said, no problem, let's do it. Happy to invite him, and so I invited him, and we went back and forth and figured out a time that he was going to be able to show up. And Anton said, hey, I think I can live stream this at the exact same time that you do. And so this is the first time anybody has ever proposed this. And I'm sure the technology to be able to do this is very complicated. But I think we're kind of pulling it off. So hopefully there's going to be some technical issues. Apologies in advance to everybody. I think you may, as you said, see a little bit of a stream delay on Anton's side. I'm looking at both the chat from the people who are on my channel and the people on Anton's channel. So I feel like we're having a party and all these people are all together. Anton, welcome.
Thank you very much, and I'm super happy to be here. And this is definitely the best party currently on YouTube. So do join in.
Space party,
exactly.
Yeah.
So if you don't know who I am a Canadian living in South Korea. I've been here since 2007, and I've been running a channel very unfortunately called What Da Math, and that's because I was a math teacher for a very long time. Started as a math channel. And basically the channel has been sort of my full-time job now for about 4.5 years. And it's basically become my life now. And this is my first time I'm announcing this officially. I'm taking a break off my full-time teaching job now to focus on this and to try to do my best to become basically a better space educator in a sense.
Oh, that's fantastic.
And we'll see how it goes. I got approval from my family to kind of do this, and let's see how it goes.
Oh, well, there you go. That's all you need.
Yeah, exactly.
So I guess we both have to say a boot for the rest of this.
So that's what I got in my chat as well. It says for the rest of the party, we have to say a boot. And what else do we have to? Oh, yeah. Okay. A.
Yeah,
all right.
I have to say A a lot.
Okay. So I actually had surprisingly quite a lot of questions already for both of us about space. And one of them really kind of bedazzled me on the spot. This person just posted it very recently. He basically said, well, I have a question for you. I can't attend your stream, but I want to ask you guys, could you theoretically surf a gravitational wave? And this is from Zachary Fluke. I don't know if you saw this question.
I do. Well, I totally saw that question. And Zachary is a follower on my channel for a while. I know the answer to that question.
Okay, because I don't.
Right. So the answer is no. It would tear you apart. So when you think about how a wave works, right? You're essentially going downhill. You're going down a slope, and the slope is constantly moving, and so you're constantly being pushed down that slope. But a gravitational wave is this stretching that is sweeping past you where you are on Earth. So right now, there are gravitational waves that are passing your body right now, and they are pulling you one way, and then they are pushing you back together, and sometimes pulling you the other way. And so that effect is so tiny that you wouldn't even experience it. But if you were really close to, say, two black holes that were in the process of merging together, they would be generating gravitational waves that were so powerful that they would tear you apart. But the thing is that the force, the tidal forces from those black holes would be even stronger. So the deadliness of the gravitational waves is outmatched by the deadliness of the tidal forces and the radiation that's streaming from the accretion disk, and all of the other things that are associated with being around a black hole. So, but you wouldn't be able to surf it.
That's awesome. I learned something new today. And so to answer your question, Zachary, no, I'm just gonna
ouch, please don't try.
Please don't try. All right.
Yeah.
I don't know if you had any questions on your channel. I seem to be having a lot of them here.
Yeah, well, like I said, we're just drinking from the fire hose here. I saw one. Why don't we take turns?
All right.
Because I see one that's there from Paradox TV, which is what new things will we find with the James Webb Telescope? I think that's a great question.
Huh.
And of course, if people don't know, the James Webb Space Telescope, it's the successor to the Hubble Space Telescope, but it was supposed to have launched a long time ago. Now it looks like it's going to be 2021. And it is a really big telescope. It's more than a 6-meter telescope. But the trick with James Webb is that it's in the infrared spectrum. So it's going to be looking at objects that are very cool in the universe. An example,
temperature-wise.
Yeah, they're cool. Yeah, they're awesome, but temperature-wise, yeah. And so examples of that are things like newly forming planets. When you have like a newly forming planet around a young star, the planets are very cool, and they're also shrouded in gas and dust. And this gas and dust obscures the light that comes from the star. And so invisible light, we can't see it, but in infrared can go through that gas and dust. And so we'll be able to actually see the newly forming planets around the stars. And then the other thing that James Webb is going to be able to do is see the first galaxies as they're coming together at the very edge of the visible universe, because they are in the infrared spectrum. And so because they're essentially moving away from us so fast that the light has been redshifted, that the right spectrum of light to look at those galaxies is in the infrared spectrum. And so those are the two really big things, but it's going to be able to sort of go after everything. All right, I get to pick one for you now.
All right, awesome.
Let's see. Oh, there's an interstellar question. All right, so Caleb Osborne asks, what are the chances that we will get a better, faster, more efficient way to travel in space?
What are the chances?
Yeah.
Oh, okay. Well, chance-wise, I'm not the one to take chances usually, but I'd say it would take us a while before we even get there. And I think it's mostly due to politics, not the science. Like, we've all heard we read the stories about, even China trying to develop new sort of propellant technologies, trying to use all kinds of things like even quantum engines to try to use technologies that don't technically exist yet, but are possible to exist. But at the same time, when it comes to the actual, physical development of the engines, it always comes down to the money and the politics. So I'd have to say it will be a while before we can develop anything worthwhile to take it to space. I think one of the videos I've made previously was actually about the biggest engine, the biggest rocket ever conceived on a piece of paper. It was the Sea Dragon.
Yeah.
And I mean, it was a brilliant design, and everything would have worked if it wasn't for the Vietnam War, which suddenly, leached all the money, and there was no more support coming to the development of the rocket, and so they had to basically lower the expectations for their program. Eventually, we obviously landed on the moon because of this, but still, it kind of removed all of the funding. And so, technology-wise, we might develop it, but I don't think it'll actually come to fruition anytime soon. I think the paper that I was recently reading was about that. I was actually trying to figure out what happened to that engine that we were supposed to create that was kind of warping space around it. And
the M drive?
It was kind of the M drive, but there was a scientist who developed.
Oh, there was the Mach effect.
Yeah, and
there was another one. Yeah.
And so what he actually did, I think he ran computer simulations, and he was able to create this model of the warp engine that would be a lot more efficient.
The Alcubierre drive.
I think maybe that was it. But
Yeah.
the whole premise was brilliant, and then suddenly, it kind of stopped, and it kind of makes you think, what happens? Like, it was a brilliant idea. Why don't people follow up on this? And so I think it really just comes down to, do we have finances, which is really why, in some sense, I admire Elon Musk for taking all these risks he's taking with all his crazy ideas, because he's just doing it because no one else would.
Yep. Apparently, there's music still going on in the background.
Okay. Let me actually see if that's from me.
It
Probably is, yeah.
Yeah, it's probably on your stream. Like you probably
Okay.
you got a window somewhere going.
Yeah. Okay, so the music is gone now. Awesome. Thank you.
Right on. All right.
All right, so what else do we have? Oh, okay. Someone just mentioned nuclear thermal rockets are the next step for space exploration. Ion thrusters for small unmanned probes. So we've already been using ion thrusters, actually. That reminds me, the Dawn is finally coming to conclusion, and it's really sad. I don't know if
super sad.
People might not know what we're talking about, but Dawn mission was actually the first mission ever to be able to orbit two separate objects in our solar system. It was a probe that went around Vesta for a while, and then we took it to Ceres, and it's still there. And it actually has a lot of ion propellant left, a lot of xenon propellant, but it's running out of that traditional hydrazine that we use for changing like pointing our cameras and stuff like that, changing slight deviations of orbit. And so it's basically almost out. And once it's out, it's just dead weight for NASA. And
I wonder, though, do you think they'll be able to come up with a way to somehow utilize the ion thruster with the...
yeah, I think so. That's what the Japanese did, right? Remember when there was a mission to Venus that kind of failed at first, and they somehow figured out after like a year of planning how to control it using some other engine that nobody thought about. And so they were actually able to place their probe around Venus quite successfully using a completely unexpected engine. I don't remember the details, but it was a pretty exciting mission.
Yeah, so one of the parts that I always find so fascinating, a good example of this is the Kepler spacecraft, right? Kepler lost two of its reaction wheels, and so it was unable to point itself anymore. And so the scientists working with the Kepler mission figured out that if you pointed Kepler in exactly the right place, the light pressure coming from the sun was balanced equally on it, and it would keep it perfectly pointing in the direction that it was pointing at. And then after every period of every observing run, it had enough of that hydrazine in its tanks to be able to turn itself back to Earth, dump all of the data, and then turn back to that perfect balance point again and point some more. And so that idea that you can use the solar wind from the sun to balance your spacecraft and allow you to point and keep doing science is phenomenal. And so I wouldn't be surprised. I really should even do an article on this, that there's got to be some engineers working at NASA who have some ways that they think they can get Dawn to keep working, because as you said, there's still xenon in the engine, even if the hydrazine thrusters are almost out. So stay tuned. I think I wouldn't be surprised if they figure out something.
I mean, it's one of the best missions we've had so far. So definitely my hopes are sort of on them succeeding as well. There was another cool question someone was actually asking me, and I think this is something I speculated in one of my videos, and also it's from a book. I totally forgot what the name of the book was, but this person by the name of Caesar. Oh, it's Caesar. Okay. He's asking, can we expect to find civilizations or some kind of life on the surface of a fast spinning neutron star? Now, I'm trying to remember the name of that book.
I know, and someone in the chat is going to mention it.
It's
not Bryn.
So the premise, and the premise of the story is like, so humans start orbiting in this neutron star, and they discover there's life there, and the life evolves super fast. And so by the time I think they just started orbiting, within an hour, the life is super advanced, and then they kind of like do something to the humans. I don't remember the details. I think they actually send them some kind of a solution to life problems or something along those lines. But anyway, the idea for, in my opinion, the idea
There you go.
for light.
Dragon's Egg by Robert
Oh, that's
Forward.
right. Yeah, there
Yeah.
we go. Thank you, Kevin. So I think the idea for life on a neutron star is actually not too far-fetched, but not the life that we obviously have on Earth. It's
Right.
mostly because it's, when you think about it, like a neutron star technically is more planetary in terms of actually structure and composition. Like when you really look at it from as a whole, there's sort of like a crust-like component. There's sort of the atmosphere component. It's very, very thin. Um, and there's interaction. So there might be something like that you could call life, but I don't know if it's like life
Yeah.
as we think of it. So
I mean, one of the things that's really interesting is, neutron stars are actually a lot more complicated now than I think people originally thought. The original, when you take protons and electrons and smash them together into neutrons on to create this star, you've got this sort of uniform neutron ball. But actually, it looks like there's more layers, and there's still a thin layer of protons in the outside of these neutron stars, and there could even be like different topological features on a neutron star. So it's not just this one singular spinning ball of neutrons. They're still super bizarre places. The tidal forces nearby, the time dilation, it's super weird. And you want to stay as far away from neutron stars as you can. So if they want to communicate and invite us, I wouldn't go. I think it's a trap.
exactly. All right, your turn.
Sure. Yeah, I'll grab one here. Let's see. Let me get one from my viewers here. There was a question here. Neil Yu is asking, Anton, what do you think about antimatter drives?
The only thing I remember about antimatter drives is that it's a common technology that you get in space games.
It's like, up on the tech tree after fusion drives. You get antimatter
exactly.
drives.
That's one thing you have to get to move faster. You get one extra hexagon. But I mean, it's possible but difficult. Just to contain antimatter enough for us to have propulsion would be a challenge in itself, I think, because as you may know that matter and antimatter don't actually interact, don't like each other very much. They create a lot of energy if they combine. So you would have to use a very, very powerful engine just to contain antimatter so it doesn't touch anything. And that in itself would probably require enough energy that we could maybe find an alternative method of propulsion using that energy that would be used otherwise.
I think it's important to note, right, that antimatter is really just a battery, right? It's not a form of energy. It's just a way that you can store energy. Take matter, split it in, or generate particles of antimatter in a large hadron collider, for example, and then take those little particles and store them in a way that they don't touch matter. And then at the time when you need, you can pop them into each other.
Exactly, make them touch. But it's definitely like it's. I think it will eventually appear. It will definitely become a reality. But as of today, I think it's just too costly for us to maintain such an engine. And even then, though, it's still, it will create propulsion and it will create enough, I guess, drive in a sense. But it won't really take us faster than the speed of light, which is what we need. We need to find a way to compress the space-time to find, like, you're not going to sit on a spaceship for 4 to 5 years just to get to the nearest star, right? It's going to take too long. So,
well, so apparently someone did the math that the Parker Solar Probe could make it to Alpha Centauri in about 6,000 years, going the fastest speed.
Sometimes it's what it feels like when when you're in the math lecture or something. It's, well, exactly. And I think, and they're talking about the solar probe right near the sun, right as periapsis, right? Like at the closest approach to the sun. But by the time it moves farther away, it's already going to be moving much slower. So it's not like it's going to maintain that speed. And at the same time, I think just finding technologies that can actually help us traverse distances faster would definitely be a little bit more important than finding ways to just have faster propulsion. Although I think if we do have an antimatter drive, one advantage would that be you can definitely colonize solar system a lot faster because we'll most likely not need as much propulsion, or engines will be more efficient.
The one I'm really hoping for is metallic hydrogen. That if you could somehow craft, I mean, metallic hydrogen has been theoretically created here in the lab on Earth. And of course, it's the stuff that's at the heart of Jupiter, as long as you've got the mass of Jupiter crushing in and to create the pressure and temperature to create metallic hydrogen. But that, the level of energy density of metallic hydrogen, that's the kind of thing that would really make Epstein drives from the Expanse possible. Where
I was just thinking about that TV show. I'm like, what
exactly.
did they actually use in the Expanse? And I totally forgot.
Yeah. Hey, Cody's Lab's watching. Hey, Cody.
Hey, Cody. Big fan. All right. So what else do we have here? Oh, this is a pretty interesting and pretty simple question, I guess. This is from LLE. Do you think Earth is a magical mistake, or do you think there are more Earths out there?
Wow. That's a great question. I mean, the thing is, like, because we evolved on Earth, we have that perspective that here we are, right? And that this is the perfect place in the universe. And we don't know how many other places out there across the entire universe would have the similar conditions to Earth. We have a sample size of 1. It's entirely possible that this, although seems super unlikely, that this is the only place in the entire universe that life has ever evolved. The other possibility is that life has evolved many places and we just have no evidence yet that these places exist. And until we find any other example whatsoever, we won't know if we're the we're sort of like the only place in the universe that can or has ever developed life. It's a really frustrating problem. What do you think? Fermi paradox. Do you think we're alone in the universe, or do you think that the universe is filled with aliens and we just can't?
Honestly, there's just there's so many possibilities, and I guess in some sense I want to believe. I even had that poster from the X-Files, but every single time I start thinking about it, it makes me realize because the universe is still pretty young. What if we're actually the first mistake? Like, we're the first miracle. It's a huge possibility. And excuse me, I remember I was making a video about it. There's going to be time in the age of the universe when it's going to be very likely for life to actually be formed. Like when all of the red dwarfs become a lot more hospitable to life, when it's kind of settled down and they're all nice, they stop flaring up so much. The chance for life is going to be like exponentially higher than it is right now. But even though there might be life somewhere, I don't know. Okay, life, yes, I would say yes. But like an actual civilization with clever aliens, not so sure. But on the other hand, I want to believe in the other thing, which is actually, I know I have so much to say about it. This is a paper I read a while ago. It was about... so the way it goes is there were a lot of civilizations out there, and they all kind of reached the same point of evolution when they all kind of develop a supercomputer and they all transfer their intelligence into the supercomputer. But because the universe is still kind of hot, it still hasn't cooled down since the Big Bang, the computer is not as fast. It doesn't actually... It's impossible for us to reach higher speeds. And so they all kind of go into hibernation mode and basically just wait for the universe to cool down, which is like a pretty clever idea, and an idea that I think I wouldn't really mind subscribing to, because when you think about it, it seems that this process of developing a computer or just developing a tool that does everything for you would actually kind of make sense. And so there's maybe
the only problem with that theory, and I mean, we could do a whole episode where we just debate back and forth about the Fermi paradox, but the only debate with that problem is that what about the alien civilizations who decide they're not going to wait, and they sort of sneak up on all sleeping aliens and wipe them all out? So there would be a evolutionary advantage to to cheating and not waiting for the universe to cool down, because you could then sort of find them all and blow up their stars and take the universe for your own. So
That's true. I think they probably have a video game about that already. It wasn't that what was that video game called? Andromeda something. Anyway, but anywho, so yeah, definitely an interesting debate. But I kind of made it a policy to just go with science, and if there's a paper, then yes, and if not, then I don't know. The answer is I don't know.
Well, I've mentioned this on my stream a bunch of times. The next generation telescope that's going to be coming after James Webb, the LUVOIR telescope, it's going to be a 15-meter telescope. And one of the things that it's going to be able to do is tell us with about a 90% accuracy if there's life in the Milky Way.
Oh, wow. I didn't know about that part. Huh.
Yeah. So it's going to be able to see a large enough sphere around the sun, around the Earth, that it's going to be able to sense the atmospheres of these other worlds and detect if there's biosignatures on those worlds and let astronomers know,
That's
like I said, 90% accuracy. In other words, if they find no life within that sphere that LUVOIR can detect, then most likely the rest of the Milky Way is going to be the same. But if they do find life, then they'll know approximately how much life there is. And one of the kinds of life that they could find is intelligent life. So it's a pretty neat idea. So it is a scientific question, and we can get an answer to it. We just need much bigger telescopes.
I just actually see a question here. It says, this is actually a good question to kind of answer because of the misconceptions that people have about black holes. This is from Dogboy. If light is a massless particle and gravity only acts on objects with mass, how does it get sucked into a black hole? And I think this is actually what I wanted to bring up here. People assume black holes really suck in things like a vacuum cleaner, and they really don't do that at all. What they actually, and I think the best example of this is, if you were to replace our sun with a black hole, nothing would actually change other than temperature falling. And so the reason it doesn't actually, the reason why it does kind of suck the light is because what it does to space around it, what a black hole does to space around it, is that it folds it in such a way that light just kind of does its own thing. It goes straight, but because space is curved now, it now kind of falls into the black hole because the space has been curved. And so it's not really the sucking process, it's just a process of curling the space around it itself to make light fall into it. So it is a massless particle, there's no doubt about that, but the light itself is just curled. And sorry, not the light. The space itself is curled and the light falls into it, following the curve.
Yeah. That all massive objects, the Earth is creating a bending of space-time. The sun is doing the same thing. And then all of the objects think they're just moving in a straight line. From their perspective, it's just a straight line. Light is going in a straight line. It just happens to be that the space itself that it's following is now curved. And so it follows that curved path around it.
Yeah. Someone's mentioning my webcam is in sync with with my voice, and as you probably know, that's from the dilation effects that are being broken. Space-time effects.
We had to tear open space-time to make this even possible, and I'm certain that we crossed the streams.
For sure.
Yeah.
Oh, there's some question about Titan. Anyway, it's your turn.
Oh, sure. Well, I like that question. I'll take it.
All right.
So, Fort NASA asks, when do you think that we will explore Titan more, and what do you think of Titan? Do you think there is life in that ocean that is under the surface or maybe on the surface? Titan is an absolutely fascinating place, and I think if I had to pick one place that we should definitely go back and explore more, it would totally be Titan. Titan is the largest moon of Saturn, and it's a really weird place. It has an atmospheric density that is more than we have here on Earth. So you wouldn't need a spacesuit if you wanted to walk around on the surface of Titan. You just need a really, really good coat and a way to breathe.
Yeah.
But you wouldn't have to deal with that lack of pressure. Because the atmosphere is so thick on Titan, you could wear a pair of wings and you could fly around with your own arm power on Titan and fly around, which is amazing, right? So, and And so Titan is a really weird place. Titan is like Earth, but it's like everything is shifted one position. So the liquid on Titan is ammonia and methane and things that are gases here on Earth. The mountains on Titan are made of water, where here on Earth water is a liquid. There it's so cold that the water becomes the mountains and the sand and the rock and the dirt. And so everything is shifted in this strange way. But the part that's really crazy about Titan is then you've got this layer on the top, but then beneath that you very most likely have another liquid ocean similar to what's on Europa or Enceladus. So it's really a twofer, right? You go to Titan and you can explore the surface and you can send submarines down into these really cool seas of methane and search for exotic forms of life. And when you get bored of that, you could drill through this ice shell and get to the liquid oceans underneath and explore that as a completely separate place. So I think that if I had to pick one place that we would go back and explore more deeply, it would absolutely be Titan.
For sure. I definitely agree with it. I think I've mentioned it several times. It's probably one of the most favorite places I have in the solar system. I've talked about it many times. And there's actually, I think, a couple of papers that do mention some anomalies on Titan, like unusual methane levels that they couldn't explain, and some other things that just don't make sense from the scientific perspective we have right now. And so there is a possibility for, maybe microbial life creating all of this stuff. There's definitely a possibility to have life on Titan because it does have the components for it. We even found things like, I think it was cyanates, which are very important for life. So there's, I personally, I think there is something on Titan, something unusual, something interesting, and we definitely have to come back. I was very sad to see the Cassini mission go. I was hoping for more ESA missions that would actually possibly take us back there. And there we go.
Blowing your mind. I'm putting up a video of a submarine on Titan.
Yeah, that was planned when I was still in college. I think I remember my professor who actually got me into the whole astronomy obsession. He showed us that video back in the days, or maybe it was actually a little bit after.
This one's fairly fresh. So I got a question for you.
Yeah.
This one comes from Cody of Cody's Lab. And he says, can you see the moons of Jupiter with the unaided eye from Mars or Ceres?
With unaided eye?
Yeah. So here on Earth, right? If you look up at Jupiter, you can't see the moons of Jupiter with your own eyeballs. You need
a telescope.
A pair of binoculars or a telescope to be able to do
it. But
from
Mars? Was he saying from Mars?
From Mars or from Ceres, would you be able to see the moon?
Well, I mean, the distance is still like, 3 astronomical units at least? I would have to say no. I don't think it would be that easy. I think you would see Jupiter and you would probably see it flicker on Mars just slightly. There would not be any flicker because there's not enough atmosphere. You would see it maybe dim a little bit if a moon passes in front of it. But not. I think you would still need at least binoculars.
So you wouldn't be able to just see, because I've heard that people have said that with really good vision in perfect skies, when the air is clear, they can actually see it.
But from Mars,
from
Earth.
But they could also just be full of it, right? How do you?
I would have to say there. I mean, Galileo had a pretty powerful telescope when he made it, and it took him a while to squint just to see those 4 Galilean moons. And back then, I think the skies were much darker too, so people were definitely seeing a lot more because of the light pollution. But I don't know.
That's a great question.
It's a great question, though. I think, well, definitely.
Sounds like a new video.
Exactly, but definitely more from Ceres, higher chance from Ceres because it's closer.
Yeah.
But still, I mean, it is pretty far away. I would really have to investigate the actual parallax that you have between the, let's say the farthest moon, like Ganymede and Jupiter or something, and to see how far away it is from that distance. Because, that eye sensitivity is really all about changes in parallax from a distance. So, for now, I would say no, but maybe?
Yeah. Like I said, now it's in your head, and now you're going to do a video on it. So.
I know the answer for me is definitely no. I mean,
right.
So I probably wouldn't be able to see the nearest rock on Mars. But anyway, yeah.
All right, you
Uh,
grab a question.
uh, okay, let's see. Can we terraform Mars? I guess that's a sort of a big question to answer. Can we terraform Mars? And I think I've made my opinion very
I don't.
unclear several times in my videos.
Oh, okay. I don't know. It's right. So the big problem with terraforming Mars is that the solar wind that's coming from the sun is constantly blasting against the atmosphere of Mars. And because the gravity on Mars is so low, any atmosphere that tries to build up into the atmosphere of Mars is going to get blown away by the solar wind.
Yeah.
So the first thing that you would need to do if you wanted to somehow terraform Mars is that you would then have to block off. You'd put like a big sunshade at the L1 at the Mars Sun L1 Lagrange point that would block off the solar wind that's coming from the sun. And what that would do is you would then get natural volcanic gases that are coming out of Mars, and they would build up and build up and build up in the atmosphere, and they would warm up the planet to the point that the poles would melt, that would probably release the carbon dioxide that's trapped in the poles of Mars, and you would be able to thicken the atmosphere and warm up the planet a bit. The big question, this is the one that sort of created this controversy in the last couple of weeks, is there enough trapped gas on Mars that you could ever not have to wear a spacesuit? And this is still a controversy that goes back and forth, whether you're Elon Musk or the scientists who put forth this.
I think the latest study did an analysis, and they basically showed that there was just not enough CO2 there. You don't have enough CO2 to even create enough atmosphere, not to mention greenhouse effect. So it sounds like the answer is no, unless we find a way to somehow bring more stuff by like colliding it with things, maybe. But even that would be too far-fetched at this point.
All right, I got a great one for you here. Fernanda Backer is asking, in the future, is it possible that we'll see new stars and planets made with heavier and heavier elements, since supernova explosions are putting heavier elements into space?
Stars. Well, usually stars end at iron, so I think up to iron we're fine. But as soon as you reach the limit, basically, when the energy is no longer created from fusion, it kind of stops at that. But I think what might happen is eventually, if everything doesn't become a black hole, I guess, in the future, there might be a time when some other effect will start appearing, especially as the universe expands and as things start interacting differently. It's possible that something else will actually start appearing that we can't even imagine right now. So as of now, I think it kind of just stops at what we have. But maybe, just maybe, in a few trillion years, things will change. Just wait. Stay tuned.
So what would happen in a few trillion years?
I'm guessing simply because of the expansion of the universe, it's possible that the fabric itself will actually start sort of acting on things differently. And maybe, just maybe, even like iron will become somehow different. Maybe it will just start producing energy, or maybe something else will happen. I would really have to, a lot of questions that are sort of hypothetical like this. I often have to do hours of research just to discover if it's even possible scientifically. Yeah. But right now, I would say, I mean, with time, anything can happen, you know? Just wait a long enough.
If you collected together enough of any element that was less than iron, you could turn it into a star and you could generate fusion power out of it. Oxygen, neon.
Exactly.
Anything all the way up to iron. Once you collected that iron together, iron is not going to generate more energy that comes out of it than is going into it. So you can't have a star made out of gold.
So my only, I guess my only sort of retort is, so we know how universe was very different in the first sort of few million years, or I guess at least first 400,000 years. And it's possible that things will still change, I guess. In some sense, there's still a possibility for elements not behaving the same way anymore. Like when space is so stretched out that, you know, like you just don't get the same interaction. But that's very hypothetical. It's definitely requires some hardcore quantum physics and a lot of interesting analysis. But yeah, for now, the answer is no. But you do get really cool, almost iron stars, and they're very different. They don't last very long though. They usually die within a few million years, so we don't get enough of them.
Can we actually see them? I know Isaac. Someone's mentioning in your chat that Isaac Arthur did a whole episode on iron stars, so people should check that out.
I would imagine that we can't see them because I don't think they produce energy to be seen. I think they just kind of stay as iron.
A blob of iron.
Yeah, a blob of iron. I'm assuming that the only sort of like dead stars we can see are the white dwarfs are pretty visible, and that's about it. Neutron stars. And that's it.
Well, and this is, back to that concept about supernova spreading those heavier elements into the universe. Now it looks like it could very well be that the vast majority of that is actually coming from neutron star collisions.
Exactly.
Which are causing supernova, but are kilonova as opposed to supernova. And so it might very well be that we don't get those heavier elements from supernova at all. And that's still now a big question. And that whole discovery of the kilonova last year really changed everything about the way people are seeing these catastrophic events.
Definitely. Yeah, I'll have to check out the Isaac Arthur's video. I'm actually kind of curious. Kind of curious about it. This is one of the reasons I decided to make the Sea Dragon video, because I knew about the rocket, but I actually didn't realize how big it was. And so he inspired me to create this because I wanted to see if I can recreate it in Kerbal Space Program.
Were you able to?
Yeah, it was pretty epic. It can actually. I have another video coming up soon where it actually can lift Saturn V, at least the second stage of Saturn V, and basically take it all the way to the orbit, and then you can use Saturn V engines to finish and take it to Mars. Hypothetically.
But it's not reusable, right? The whole thing is just
the lower stage is. Their plan for Sea Dragon was that you would actually have this humongous inflatable raft slash I guess it's like a parachute raft. It's like a thing that inflates and slows down the descent and then splashes into water. And so the lower stage was actually, the first stage was reusable, the most expensive stage. The second stage was not. And so there's definitely a lot of reusability in that rocket, and it was made from cheap parts. It was actually very efficient. There was no need for any takeoff operations. You basically did everything from the water.
Yeah, it's just floating.
Yeah, exactly. And then you just kind of like lift it up. And
did you have to do anything to? I should bring up your video. Did you have to do anything to mod the game to let you do a Sea Dragon launch in Kerbal Space Program?
Well, someone already made a model, and I left the link in the description. And I only had to change it to the realistic solar model. I think it's called RO or something like that. And that's because the Sea Dragon is so powerful that if you actually launch it in the regular Kerbal Space Program, it literally just destroys itself because it's so powerful, and it destroys everything on below you as well. It has way too much power. It's ridiculous how powerful it is.
I found it. Yeah. Hold on. Let me put this up for people here. I'm just going to put the audio here for a second. Oh, that's amazing.
I think the audio is not playing, but that's okay.
Yeah, I put the audio on it just for that.
Oh, okay. I guess I don't hear it from my end. I may have to.
Oh, yeah. Okay.
I might have to take your video after because mine is not really the best quality here.
Oh yeah, you could do that. I'll download a copy and then put it on.
Okay, that's awesome.
You could probably just rip it. I'm sure you can think of a way to do that. But awesome. If not, I can download a copy of it for you.
But yeah, that rocket was actually, I forgot why we started talking about it, but it's a pretty incredible. Yeah,
because all roads lead to the Sea Dragon.
Exactly. Yeah,
it's every conversation about space flight just turns into a conversation about the Sea Dragon.
But here's the kicker, though. Apparently, the guy who invented it, he had smaller models made, and he actually tested them, and they worked just fine. So he had one called CB, which was really small, and then he made another one, bigger one, that was basically the size of a typical ICBM. He called Seahorse, and they tested that as well. And there's actually videos online that someone stored from like back in the 90s. Someone collected all these videos of the rocket being tested, and it was all running fine. And I guess people were really excited about it, but well, money ran out, so.
That is awesome. I love the concept. I really think that we're sort of at this place now with what SpaceX is doing, especially with the BFR. If they can make the BFR work with the reusable top stage and the reusable bottom stage, then you've got this fully reusable spacecraft that you're using. Every part of the spacecraft comes back to Earth and can be reused. And I think that's the holy grail. Every other rocket system then will just be an adaptation of that model, because there's something really magical about not having to throw out your rocket every time you use it. I mean, this is the tragedy of the NASA's Space Launch System, right? It's going to be running 4 of those beautiful RS-25 engines that came from the space shuttle. Easily one of the most efficient engines ever made. These things are expensive. They're the Ferraris of rocket engines.
Exactly.
And each one was lovingly refurbished after every space shuttle launch, and now they're going to take the things and just burn them up in the atmosphere, which is heartbreaking. So to see things like the BFR, where things going to launch, both the two halves are going to separate, they're going to land, and then it's going to do the whole thing again. Right?
Yeah,
I can't believe it. I can't wait for us to be able to be in that place.
I don't know if you've played the Surviving Mars game that was released by Paradox. They kind of sort of copy that idea in how you land on Mars, and it looks brilliant. It's just like you land on Mars and the rocket refuels on Mars and just takes off again. Why did nobody think of that before?
Well, people have thought about it. But I mean, why did nobody
designed
try
it,
to
right?
build a 2-stage completely reusable rocket?
But
actually, the Mars 2020 rover is going to have it's going to have an experiment on board that's going to be generating rocket fuel from the carbon dioxide in the atmosphere. So they're going to be doing this test to see if they actually can pull out the carbon dioxide and turn it into potential rocket fuel. And if that works, then a future spacecraft rocket factory will go to Mars, land, and produce all of the fuel that the astronauts will need before they can come home. So
there's actually a really cool question here from Rastian. Why do you think governments are not interested in the space race anymore? And it's really kind of, it comes down to, why did space race even start?
Yeah.
And I think it was just a big sort of saber rattling of two countries trying to compete with each other. And I think this is what's missing now. We're missing this competition. Like, nobody is really trying to outcompete themselves, except for maybe 2 people. And those 2 people are Elon Musk and Bezos from Amazon. They're basically the only 2 crazy people crazy enough to actually create something.
Well, right now, there's actually like 5... different groups that are working on sending humans to the moon, right? So there's NASA is potentially going to be going back to the moon as part of the SLS and the Orion system. You've got SpaceX. You've got I think Lockheed Martin is working with Bigelow Aerospace to send inflatable habitat to lunar orbit. You've got the Chinese, who are absolutely going to be sending people to the moon. Like, this is all part of the plan. So I think that there's one more and I forget, but there's actually, now there really is a race back again. And I think people will be surprised how quickly. I mean, one of the things that the SpaceX, the BFR is going to be able to do, just as a cool side effect, is do things like land on the moon and return. It's just, just one of its capabilities will be able to do that. So I think that it was a race in the past because it was like the dominance to show that you could drop nuclear weapons anywhere on planet Earth, right? You wanted to show your enemy that you could hurt them where they live. And it nearly bankrupted both economies to be able to make those happen. I think the spending during the Apollo missions was about 10 times what it is today. So now now those flags have been landed, right? So what is the point of going back to space? Now it's for economic reasons. Now it's for sort of deeper, more exploration and uh, science reasons. So I think, and it's going to have to be cheaper, but I think this time people are going to stay.
Hopefully.
Yeah.
Although, having been to China several times, I'm actually surprised how it seems that the interest in actual space exploration, like from a regular public, is almost non-existent. I was
Really?
actually surprised how, um, I mean, compared to, I guess, anywhere I've been to, it seems that people don't really care about it as much as other
Hmm.
like as other more common things like I don't know online shopping or and it seems to be more of I think it's a more of a cultural thing where they kind of just adapt to one thing and they all go into it. And so the government is pushing them to be interested in space, but there is unfortunately just not enough, I guess, kind of a internal interest. And this is actually interesting. I've mentioned to you previously that both of our videos were actually unofficially borrowed by a few
Yeah.
space enthusiasts in China. And for those of you who may not know, apparently well, at least Fraser here is a celebrity in China without even knowing about it.
Apparently.
But interestingly, they do have like 8 million followers, which is a huge, huge number
Yeah.
for, when you think about like, I don't know, like us having 8 million
Yeah, my
followers.
my Chinese videos have way more subscribers than my English videos.
But the interesting thing is that when you really think about the population of China, the actual percentage is so tiny compared to some other channels that they have
Yeah.
that it really shows you how there's really not that much interest after all. Even though it's 8 million, there's like 1.3 billion of people, so it's technically not that big of a number. At least that's how my Chinese friend explained it to me.
Right.
I was really trying to argue with him. Are you sure you guys are not interested in space? I was actually asking him to see if we can actually create some kind of a space thing, and
Yeah.
it's difficult. It's very difficult to do it in China because I think right now it's the government doing it, but not so much actual like people. They're not as interested.
Yeah. But yeah, I'm totally fine with it. If somebody wants to rip off my videos and add translations and put them in in another language, I'm totally fine with that. Feel free to do that. Go
Yeah,
crazy. Actually, some people that do that in Russian and Ukrainian, I think, as well. And I know some people do it in Spanish and Portuguese. And it's very weird to me because the ones that are super weird is where people will actually do the voiceover. And so I'm just like there and I'm talking and then I'm speaking Russian with a completely different voice. And
that's pretty awesome.
yeah,
I hope someone does it for me too.
yeah, totally fine
Just so
with
I can keep it for posterity. That's awesome. Okay, so what else do we have? So there are a lot of questions about aliens and type 3 civilizations.
yeah.
Aliens seems to be a big topic here. Um, cool. How
We got about
long?
5 minutes left.
Oh yeah,
So
you're
it's got to
right.
be a good one.
Oh, okay. So you guys gotta ask a good question. We're gonna put this weight on you. One last question. Amazing question for either one of us or both of us.
Yeah.
Because I think a lot of those questions that were asked previously, someone else actually answered them, which is great. I love having this party where things just happen. People just answer the
People are
questions.
answering questions as well.
Yeah.
Well, actually, before we go into any other questions, I would love to know sort of, what's going on with you. What are some upcoming videos that you're working on? Where can the people who are watching this on my channel find out more about what you're doing?
So I basically make a video. I try to make a video every day. I've kind of been successful more or less in the last few years, but I may have to slow down because it is very taxing. But the few upcoming videos are going to be follow-ups to the Sea Dragon. I'm going to be talking about. Actually, let me check. I totally don't remember. I'm going to be talking about some hypothetical scenarios of what would be different if Earth was different. There's going to be one video discussing. Oh, okay. That's my folder with all the stuff. Discussing all of the Earth historical differences, like how Earth actually changed throughout the ages. And this is the kind of stuff that I usually make on the channel because I tend to explore it scientifically, but I also want to sort of answer hypothetical questions that people might have. What if Earth was this? Let's do science. And what
What if
if
it was like double the size.
Exactly. Or
Yeah.
even better, like what if, life never evolved? How would Earth look?
Yeah.
Um, Someone was asking me a question previously, how did sun form from just gas collapse? How does it work? So I actually made a simulation that I'm going to be posting next week where I show you how the gas collapse actually creates star-like objects. And it happens every single time, no matter where you put the actual gas particles. There's going to be answers to questions like different planets you may have not known existed that are absolutely mind-blowing, like just
Yeah.
stuff like that. And it's usually all realistic things that actually do exist or scientific things. So I don't deal with like aliens unless it's a science, or I don't really do things that are too extreme. And
Nick Dolce is saying in your chat that you have a Patreon. So, and this is key,
yeah,
right? If you're going to go full time making
exactly.
videos, then I think everyone who's watching and is a big fan of Anton's work should go to patreon.com/.
Yeah, and thank you so much, Nick. He's actually been a supporter for a long time. The only thing is that I've actually, like I said, this is my first year actually doing this full time, so I'm going to be changing up a lot of things. I want to do a lot more streaming as well. There's a few unfinished projects. Like people have been asking me to finish this absolutely terrifying alien isolation game, which I don't know if you've ever seen or heard about it, but
I've played it. Yeah, I've got it.
I fear quit it. I couldn't do it, but I want to finish it. And there's just things I want to do this year just to show my appreciation for all the support, but also to kind of really create this kind of a learning channel for people that are interested in science and want to learn through specifically video games, because that's kind of how I started. I wanted to do more video game education. I mentioned in one of my sort of intro videos that I actually learned pretty much everything I know through video games, including English. I didn't speak English until I started playing Diablo back in the days, which is pretty, yeah. And so there's a lot of things that modern video games have to offer. And so I'm trying to show this sort of scientific side by using all of these video games I managed to find over the years, and a lot of them have been made by amazing people, and some of them are actually absolutely free. Like Space Engine, which I use a lot, is absolutely free. And
Yep. Awesome. What's my next video? I did a video on Pluto and what's up next for New Horizons and some of the interesting discoveries, but also that there's some plans in the works to send a return mission to Pluto. So maybe an orbiter, maybe a lander, something like that. And then after that, I am working on an episode on the ice cube neutrino detector. So I'm talking about like how neutrinos are detected by this, how they're generated, how they were first discovered, and some kind of more exotic ideas for neutrinos. Could we use them as a communication system, things like that? So could very well be that we could scan the sky, scan the universe for messages from aliens using neutrinos. So I've got a couple of episodes in the works. I don't do one every day though, although I guess I kind of do. If you look at all of the various with Astronomy Cast and the Weekly Space Hangout, and the big thing that we've been doing now is I hook up a telescope live into a live stream and take
that's awesome.
Yeah, so it's like I'm a DJ but with a telescope. And so people are like, let me know what you want to see.
That's really cool. So, but you have to live in a really dark area for this. I'm kind of jealous.
It's a remote telescope. It's operating out of a dark sky area in California. And so I just use it through the internet. Big thanks to Oceanside Photo and Telescope. They built the telescope and then I get to use it. So
that's really awesome.
Yeah, so we do that. We're doing that on Twitch, and I'm doing that a bit on YouTube as well. So maybe some night you'll join me and we'll do some astronomy.
That's really cool. That's really awesome.
As opposed to simulation.
Yeah, exactly. Yeah, real astronomy as opposed to just video games.
Yeah.
That's awesome. All right. So any more last questions here? Let's see. People are asking me about Elite Dangerous. I do play that, but it's not my full time.
Too hard.
It's too hard. It's too complicated. And it's so much time that you need to commit to it.
I've reached sort of video game singularity. Everything I just play is RimWorld now.
Oh wow. Okay.
That game is the perfect game for me. And that's all I play. Well, we've reached the end of our hour, and we should wrap this up. Clearly, I think people enjoyed it. We should do something like this again in the future.
For sure.
It was super fun. I'm always happy to jump in if you want someone to co-pilot when you're doing some episode about you're going to smash things into other things. I'm happy to hang out and ooh and ah with you. Everyone, I put a link to Anton in the chat. I'm going to in the show notes, and I'll put the cards and stuff at the end screen, so you can go to his channel. And if you're listening to this on the podcast, do a search for What Da Math, and you'll be able to find all the stuff that he does.
And same thing for me. So everything is going to be in the description. Check out Fraser's channel. It's absolutely amazing. I've been a huge fan for a long time. How long have you been actually doing this? Because I remember trying to look it up, like decades.
How long have I been assigned? I've been doing Universe Today for 20 years.
Yeah, that's right. Yeah, it's insane. It's just this is my dream now.
Yeah, well,
stay in a game for 20 years.
Possible. You can skip a lot of the mistakes that I made. So you're exactly on the right track, man. You're killing it.
Awesome.
And I'm really enjoying the content that you do, and I can't wait to hang out again.
Oh my God!
Just gave you 100 euros.
What? Oh my God! Thank you so much, useless companion. That's the name of the person. I'm sorry. Oh wow! Thank you so much. This is crazy.
All right. I'm gonna stop my stream, but you're gonna have to stop your stream separately.
So thank you so much, and I hope you guys enjoyed this. This was actually super fun.
Yep.
And maybe we'll get to finish Alien Isolation with Fraser Cain next time.
Oh no!
All right.
Flashbacks. All right. We'll see you later, everybody.
Take care. Bye bye. All right. So stop. All right. Thank you so much, guys. One more time, and you're still here. Hi. I'm
still here because I stopped my stream, so I'm no longer streaming on mine. But
all right. So I need to stop my stream here. All right.